Today we are going to see the new chapter, that is matrices from the part 1. This is second chapter from part 1. Okay, this chapter is very important according to your board exam because there is compulsory 2 questions on this chapter in your board theory exam. One question may be for 3 or 4 marks and one question is compulsory for 2 marks. They can ask that in the MCQ also or in short question also. Okay, so let's start with the matrices. Matrices you have already seen in 11th standard, but what is the meaning of matrix? Okay, matrix, there are so many types of matrices are there. It is 2 by 2 matrix, 1 by 1 matrix, that is known as order of the matrix. Okay, so matrix is diagonal arrangement of number or imperfect arrangement of number are known as matrices. For example, suppose this is matrix 1, 2, 3, 4. Okay, this is called row 1, this is called row 2. Okay, this is called column 1, this is called column 2. So row 1, row 2, column 1, column 2. So in this matrix we have 2 rows and 2 columns. So we can call this is 2 by 2 matrix, or it is also known as order 2 matrix. Okay, suppose like this 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 3 rows, 3 columns in this matrix. We can see row 1, row 2, row 3, column 1, column 2, column 2. Okay, this is called 3 by 3 matrix. Okay, the matrix in which number of rows and number of columns are equal, that matrix is known as square matrix. Square matrix means the matrix in which number of rows and number of columns are equal, that is known as square matrix. Okay, now 1, 2, 3, 4, 5, 6. What do we call this type of matrix? In this matrix, there is row 1, row 2, but column we have column 1, column 2, column 2. So 2 row and 3 columns. So order of this matrix becomes 2 by 3. Number of rows we always write first, then we write column. Right? Is it a square matrix? No, it is not square matrix. Why it is not square matrix? Because as we know the definition of square matrix, the number of rows and number of columns should be equal, but here number of rows are 2 but number of columns are 3. So this is not square matrix. This is just simple matrix of order 2 by 3. Okay, after that we have to find determinant also of matrix. You can find out determinant of matrix of only square matrix. Okay, for example, suppose A is any matrix 1, 2, 3, 4, and you have to find out the determinant. So determinant is given by mod of A, right? So 1 into 4 is 4, minus 3 into 2 is 6. So 4 minus 6 becomes minus 2. So modulus of A is minus 2, right? Similarly, if you have any matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. This matrix of order 3 by 3, right? How to take determinant of this? So determinant of A, 1 is constant. Give the row and the column, take 5 into 9 is 45, minus 8 into 6 is 48. Then minus 2 here. Give the row and the column, 4 into 9 36, minus 7 into 6 is 42. Okay, then plus 3. Okay, here we write positive, negative, positive. Alternate sign we have to give. Leave 3 in the first row, third column, leave that one, that column. 4 into 8, 32, minus 7 into 5, 35. Like this. Okay, so you get 1 into 45 minus 48 is minus 3, minus 2 into 36 minus 42 is minus 6, plus 3 into 32 minus 35 is minus 6. So you will get minus 3, minus plus 12 and minus 9. So minus 3, minus 3, minus 3, minus 3, minus 12 plus 12, 0. So determinant of this, okay, what you get is determinant you are getting 0. So when your determinant is 0, that type of matrices are known as singular matrix. Okay, singular matrix whose determinant is 0, that are known as singular matrix. Okay. Okay, so next point we have to see that are types of matrices. Okay, there are so many types of matrices. that we have already seen, that is identity matrix. Okay, identity matrix means the matrix whose diagonal elements are 1 1 and non-diagonal elements are 0 0, that are known as identity matrix. Okay, then number 2, square matrix. That also we have seen. Square matrix. Square matrix means the matrix whose number of rows and number of columns are equal. That matrix are known as square matrix. Okay. Number 3, singular matrix. What is singular matrix? The matrix whose determinant is 0 is called singular matrix. Okay. Then number 4 is non-singular matrix. Singular का opposite is non-singular. The matrix whose determinant is non-zero, that is non-singular matrix. Okay. Number 5. The next type of matrix, actually we have to take it later, but let's write that matrix type first. Invertible matrix. This is one point in our chapter. Invertible matrix. The matrix whose inverse exists, that type of matrix are known as invertible matrix. Okay? Invertible matrix, the matrix whose determinant, inverse exists, that type of matrix are known as invertible matrix. Then is it possible that all the matrices are invertible? Is it possible we can find out inverse of every matrix? So their answer is no. Why it is no? Because we can find out inverse of those matrices whose determinant is non-zero. Okay, it could be negative, it could be positive, but we can find out inverse of those matrices whose determinant is non-zero. It means that matrix should be non-singular. We have seen the definition of non-singular matrices. The matrix whose determinant is non-zero, that matrix are only non-singular. These 2 points or these 2 types are related. That's why I have taken it here. But we have to see this invertible matrix later after first exercise. Okay, so this is the concept. Now, the next thing, as I told you, there are so many types of matrices. Singular, the matrix in which you have same number of rows and column. Sometimes you have a different number of rows and column. At that time, what we do? At that time, we have to apply some transformation. Okay, what we have to do? We have to apply transformation. Apply transformation. So what transformation we have to apply? Suppose we have any matrix 1, 2, 3, 4. Okay, here we know it is row 1 and row 2. Okay, and question is apply R1 interchanging with R2. This operation we have to apply. R1 interchanging with R2 means this R1 and R2, row 1 and row 2, you have to change the position. So if I apply, what would be my solution? Matrix would be same, that is A. So 3, 4 become your first row and 1, 2 become your second. This is called apply of transformation R1 interchanging with R2. Same matrix, if I apply column 1 interchanging with column, what will happen? Column. What is the first column? 1, 3. That becomes your second column because C1 and C2 you have to interchange because this is column 1 and column 2. Okay? 1, 3 becomes second column, 2, 4 becomes your first column. This is called transformation or application of transformation. Suppose you have any matrix like this. A equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the matrices. Then this A matrix may we have to apply this transformation. R1 changing with 2 times R1. Okay? Matlab R1 to you have to multiply by 2 times R1. And then you have to apply C1 tends to C1 1 1 by 3 times C1. Means C1 को you have to multiply by 1 by 3 or simply C1 you have to divide by 3. So first I will apply the first operation, that is R1 interchanging with 2 times R1. So what I will do here, I will apply this operation to this R1 only. You have to make changes in R1 only, R2 and R3 will be added. So 4, 5, 6, 7, 8, 9, that is as it is. Then multiply R1 by 2. So you get 2 into 1, 2 into 2, 4, 3 into 2, 6. Correct? Then you have to apply this C1 when you have to make changes by multiplying 7 by 3. So you have like this. C1 you have to divide by 3. This is your C1. So you will get 2 by 3, 4 by 3 and 7 by 3. Baki 4, 6, 5, 6, 8, 9 and 3. Okay, this is your